Good morning, everyone. A very good morning. Shall we begin the session? Yeah, today's topic is the same, that is implementation of the regular expressions and the CS script. In the last class, we have studied something about the regular expressions and how they perform, or what are the various scripts that is used in this, what are the various text processing criteria by which we can exchange, by which we can use the CFML. So let's begin with the four REs again in the CFMX. What are the four REs? One is the RE find, then RE find no case, then RE replace, RE place no case. So there are four REs in the CFMX. And the first two functions used for searching are identical with the exception that the first is the case sensitive, second is the in-case sensitive. That is the case insensitive. That means there is a requirement of next part is taken out at the first two functions that is used with exception that first are the case sensitive and the case insensitive. So this is the regular expressions as a symbol pattern in the text string that is given as a second argument. And a string which is to be processed, there is a regular expressions identifying the substring and the new substring to replace the identified substring. In this case, we are using the second regular expression function that is the refind no case, which is used with the regex string start and sub expression for passing the text in the agent2.cfm template. So whatsoever the template, whatsoever the data we are using up, that is used in the refind no case. And syntax for operating for framing the regular expressions is based on the set of the operators, character classes, and or portable operating system interface, that is the POSIX classes. This description is used with the RVB, that revisiting the search engine, how the search engine will be implemented, how we are using the writing the cold fusion, that is included in the cold fusion, that will be a part of the cold fusion. So this figure explains the content of the function. What is the main content of the function over here? And given the document of the registered collection, the indexing function processes each document by parsing, that is identifying and marking each word of the document. We're building a frequency list containing each different words appearing in the document, each word that will be occupied. And when parsing of all the documents is completed, so there's a word frequency list for the whole collection has been generated out. And for each recorded word, links have been established, links have been used to all the documents in which the word occurs. This is the more text. This is the read text, read a word, new word, index, end of the file. So this is the logical diagram, how the end of the file will reach or how to use the indexing process. So the result will be an inverted index of the word, each with the frequency of occurrences in the document collection. So these documents containing requested words can then easily be localized by means of the index. And based on the each word total frequency in the collection and its local frequency in the document, different kinds of scores of relevance for the individual document can be computed, can be used. And in the following example, we demonstrate how to construct a template, how to use a template that reads a text file, that reads or passes the text by means of a regular expressions and builds an inverted word index for the document. So whatsoever the index we are maintaining out, whatsoever the data we are giving up, so that used for the demonstration that completes. So application has a introductory form by means of which you can upload your own text files, upload your own data files, we can say. And this application manager also have an introductory form by means of which you can upload your text files on text files. Next next file that is used is the parcel.cfm that uploads, passes, and prints the result from the specified file. So this introductory index.cfm file is very simple. So this is the index.cfm. There is a h3 tag with the font color blue, text file index string. Font will be closed. Then cf form action, that is the parcel.action or cfm action method is post. The name of the file that have a name, file name. Then there is a submit button. So purpose of this template is to permit the user to specify a text file at the client computer for uploading to the server for processing. So this uploading will be done on a client machine. This uploading will be done for the processing. The next step is to search sequentially through the text string in the file to identify each separate word, each separate record that exists or not, that incremented or not, that is used with a frequency counter or not. And for each existing word, its frequency number or counter is also incremented by 1. And when each and every document is exhausted, that is done, so words are sorted in descending order with the most frequent on top of the list. So in the following template, parcel.cfm, so you specify the index.cfm file that is uploaded, that reads it into a variable that is a file up as a string value, and its characters are counted out. So the core of the process is surrounded by two pairs of CF loop tags, one nested in the another, and the both functions are used as a while loop. First, starting at the line 8 and closing at the line 26 is also traversed as many times it is processed to identified words. So this is traversed for each character in the word. And core of the parsing process also starts by finding each words. This is done by line 9, in which the position of the end delimiter of the current word is also identified. And since the beginning is the character following the end delimiter of the previous word, so these words can be also be extracted by the tag of the line. So whatsoever the data, whatsoever the finding that is available, that process starts with them. And the position of the delimiter following the end of the current word is also found by means of the function refind_no_case, in which the criteria for finding the next word delimiter is a regular expression appearing as the first argument. So in this template, two POSIX classes are required. One is a function, one is a space. I note that in the function, the square bracket must be repeated, that must be correctly interpreted. So the first class matches most punctuation characters not appearing as a part of the English words, but the second class matches a space, and as indicated, these results are also a part of the regular expression that is based on the character results or character classes. So whatsoever the position that is given at the end of the word and the starting of the word. So three arguments needed for the string function, that is a mid in line 10 extracts the word as available words. And this line 11 to 20 determines if the current word already is in the frequency list that has already been recorded. The frequency number is incremented in the line 16, and if not, so we inserted the word and the new word is also extracted and tested against the list of the words. So this is the parcel.cfm file action, that is upload, file field, file up, destination is given as a path, the name conflict is given as a override. Then in the next line, cf file action is again read, file is the path, file up.txt, variable is the file up. Then cf set document size is the len, file up. This will be also be used for the path, destination, non-conflict, override. So these are given as a frequency structure, as a struct new, as a character processed. Characters processed is less than document size, then REFI no case. Yeah, this will be available as a coding part of the CFMX. So frequency structure is a struct new, character process is 0, condition is given as a character process less than document size. Then position is given as a refind no case, punch and the space, then file up start. So this word will be given as a mid, file up start position start, then CF set, hit is 0, counter is 0. So the next part is given as a set new, that have a frequency structure, that have a document size, that have a len of the file up, then have a start 1, Then condition is given as a character process is less than document size. Then CF set position, that will be given as a RE find no case. Then punch space file up start. Then word is given as a mid of the file up. Then start position start. Then CF set hit is 0, counter is 0. Within the CF loop, condition is given as a counter less than struct count frequency structure and the hit is equals to 0. So whatsoever the data, whatsoever the file that will be used, that will be available in the struct key exist. Then frequency is given as the struct find frequency structure word. Then struct insert frequency structured word frequency plus 1 true. This will be given as a struct in. This will be given as a frequency structure. Frequency part will be given as a keyword. Then hit is given as a 1. Wherein the hit, which is used as a CF, it will be closed. The CF set counter is again incremented by 1. That the counter value is incremented by 1. The value will be closed. Then check the condition if the hit is equals to 0. If it is 1, then it automatically converts the incremented by 1, but if it hits is equals to the 0, then CF set struct int or insert frequency structure is word 1. So whatsoever the frequency structure that is used, so that the frequency structure will be available within the word 1. Then CF will be closed. CF set start position, start is given as a position 1. Then character process, this character process line words plus 1. Looping will be closed. Then div align is center, so we are giving the alignment as center. We are giving the h2 tag as a focal as view, what frequency list, what will be closed, h2 will be closed, div will be closed. Then the table align is center, what is